Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
Okay, next up I've got what I would probably call the dream team of crypto and all things X9 and hybrid certificate related. I'm going to call up David. Would you mind grabbing the mic on your way up so that you can each have a mic? And Mike. Yeah, Mike and Mike. Jeff, I'm going to give that one to you.
Thank you.
You need to grab it.
So I'm going to. I'm sure everybody has met these three gentlemen on various occasions throughout the day, if not in the passage of your career. I'm going to leave these gentlemen to quickly introduce themselves, and then we'll go from there. So, gentlemen, I give you the floor.
Thank you. So this is a panel, but we have a couple slides put together. We're going to talk about the draft X9.146 standard. Just as a reminder, X9 is accredited by ANSI to develop national standards for financial services. But in addition to that, X9 is also designated as the TC68 Technical Advisory Group for the U.S. TC68 is the ISO financial services. And in addition, X9 is also the Secretariat. So there's a lot of interplay between what's going on in the U.S. and what's going on in the international world in financial services. The rest of the slide you can all read. This is the terminology we're going to use for this talk. So when you think about X509 certificates, we call out classic certificates, where you have a single public key and a single signature. We also coined the term chimera, aka catalyst, dual key, whatever you want to call it, where you actually have two public keys and two signatures. One of them is in what we refer to as the native fields, and the other are what we refer to as the extensions, because these are in the actually V3 extensions. We're also going to talk a little bit about composite certificates, chameleon certificates, which they have a DDT extension, which you can use to dynamically generate your second certificate. So that's the terminology we're going to use. What we did is we created a new TLS extension. So this is not an extension inside an X509 certificate. This is a new extension in the TLS messages themselves. And these are the values that we have created so far. And again, this is a draft standard, work in progress. So default 0 means I've got a classic certificate. I'm only got native fields. I have one public key, one signature. That's to be backward compatible with whatever's out there now. Then we have native. Native says, I've got a chimera certificate, but I want you to use the native fields, ignore the alternates. Alternate is the opposite. I have a native, ignore it, use the alternates. And then, Mike, I think it was in ICMC 23 where you recommended we include both. So we did. We have both. There's been so much work in the ITF. We've included composite, chameleon, and then also the concept you had with two different classic certificates. So that's been added. The rest of the numbers are reserved. And then one of my favorites is external. Just means, okay, I'm sending you this extension. There's going to be a policy on how we're going to negotiate and use our certificates, but it's not in the message. It's in this other policy management system that has yet to be defined. And the reason we did that is we're thinking about using this extension not just in TLS, but possibly other protocols as we go forward. Now, we took a really good lesson from the ITF.
Can I back you up a second?
Absolutely.
Can I back you up one slide?
Maybe.
And
Yes.
maybe I'll back you up. I've commented on this level, but maybe I'll back you up even further. Given that this is a panel, who are you?
I'm Jeff Stapleton.
Okay. And who are you?
David Hook. Yes.
And who are you?
Mike Ounsworth. So Jeff, you're with Wells Fargo
Yes.
in addition to working for X9. David, I'm sure most people know by reputation. You work for Bouncy Castle Keyfactor, the implementer of all
Guy
things
on the
good.
T-shirt.
Yeah. Been
And
there,
Mike,
got
you
the
are?
t-shirt. And I'm Mike Ounsworth. I work for Entrust, and I'm very active in IETF. Okay, so this slide, I think what's interesting about this is if I understand correctly, we're effectively adding a TLS mechanism that allows you to negotiate the type of certificate.
Yes.
TLS today allows you to negotiate the type of crypto, but we're hitting the problem of we actually need to negotiate the type of certificate separately from the type
And
of
a good point.
crypto.
And in addition to that, not only the type of certificate, but in the case of the Chimera, we're also giving you instructions on how to use the fields. All right. I have a tendency to go through this pretty quick. So these are the values, right? And this is in the CKS. So it's a 1-byte field. It's very small, very easy to use. And can I go to the next slide? You sure? Okay. Told you it's a panel. So we did take a lessons from the ITF. We decided instead of creating a standard and hoping somebody might implement it and it might get adopted, we're actually doing beta code testing right now. So the people who have been working on this is we have Mike from Entrust. He has been assisting us developing this standard, has really good comments. I tried to make him editor for a while, but he said no, so I guess I'm still the editor. We got Tim Hollowbeek engaged with DigiCert. He is actually the X9F5 workgroup chair, and he's also the co-chair of LAMP, so we have a good connection back into the ITF. And then as far as the proof of concept, we have Anthony Hugh from Wolf SSL has provided us beta Wolf Crypt. David Hook from Keyfactor has provided us beta Bouncy Castle software. And we now have Max Palo. We hired him over at Wells Fargo. He's working on composite certificates and OpenSSL, but he hasn't done that yet, but he's still work in progress. So up to this point, and actually, David, I'm going to turn this over to you to talk about the testing you've completed so far.
Yeah, so look, I mean, actually, first thing I'd like to mention is Roy Besmier, my colleague. So he did a lot of the actual legwork on this. But yeah, I mean, it works. That's probably the most important thing. There are a few interesting takeaways from it, though, and I suspect Michael probably want to talk about this a bit further. One of the things with the alternate certificate, I'll just concentrate on that mainly because that's what we've actually got working now. I guess for a lot of us there was this kind of perception that, you know, the fact that we had this second key and everything, it would just be a matter of dropping the certificate in and then everything would kind of happen by magic. But what you do realise actually is that you do actually have to tamper with the protocol, and a lot of the work that's actually been done over the last 12 months has been trying to minimise the amount of tampering required with TLS to actually get this thing to work. And it turned out to be, I wouldn't say it was trivial, would you? Yeah, would you? No? Yeah, right.
Hey, I just wrote the words. You guys did the code, so don't ask me.
So yeah, I mean, anyway, I'll hand over to Mike now because I think this is actually a general issue with the alternate certificate stuff. Like as far as cert path API and stuff goes, it's obviously really easy to drop something like that in. But if you're then actually going to go forward and use it in a protocol like TLS and that, you actually do have to do a bit more legwork than you might think first up.
Yeah, I think that's exactly right. So if you've been to either of my talks so far this week, you'll know that my focus is migration. This is going to be hard. How do we make it less hard? I throw around a lot of words like backwards compatibility. Can these mechanisms be done without breaking anything, without having to push patches to clients? Like that's really where my head is at. As soon as you have to patch clients, things get complicated. And so this, as Jeff said, with this has expanded. It started with the alternate certificate, alternate public key format, which carries a bunch of names. ITU 2019 subject alt pub key. It's also called Catalyst. It's also called Chimera. It's also sometimes called Hybrid, very confusingly. So it started with that thing, and then your work has expanded to cover other types of hybrids, composites, and chameleons. And to me, the interesting question is that this work has answered is the value at first blush of this. Oh, sorry, Draft Truskovsky is the other name of this thing. Sorry, Alexander. And so that thing, when you look at it, you say, oh yeah, we'll put the keys in a non-critical extension. Great, that'll make it backwards compatible. So then this work here says, well, how backwards compatible? Let's try using it in TLS. Does that backwards compatibility property that it looks like it should have, does it carry over to TLS? And the answer is, I think, resoundingly, no. You need to modify TLS in order to use this in a clever way.
Yeah.
Right? I think that's the first immediate result of this work.
Yeah, I can tell you, and you may ask, like, why in the world is X9 looking at ITF stuff? And the reason we started thinking about this, and this work started several years ago, is in general TLS, and shoot me if I'm wrong, but I'm going to make this statement anyway, the client reaches out to a server that it may or may not trust. So the perception is that the client is taking the risk talking to this server. So it wants its certificate, it wants to authenticate, and so on. Well, I'm in the financial services world. And in my world, it's the complete opposite. I'm the service. You're connecting to me. You might be doing a $5 credit card transaction. You might be doing a $1,000 debit card transaction. You might be doing a $1 million wire transfer. You might be doing a $10 million remittance transaction. I'm the guy that takes the risk. And I'm worried about the client. They're the real client. It's the real account number. So my perception is very, very different. So that's why we started looking at this, trying to figure out what was a good way to do it. And ultimately we decided, I think we're going to have to do a TLS extension.
Yeah. So one of the, I mean, that's the thing. There's been a lot of discussion about, you know, the extra overheads associated with including PQC certificates and then user experience in terms of, you know, what it looks like on the browser. But in one of the, I guess, simplifying factors about this particular problem is that with a banking application, the user experience is good if the customer gets the cash and the Russian mafia don't get the credentials. After that, everything is icing. So yeah, we didn't have to worry too much about overheads. But yeah, sorry.
So, I mean, I think this work is already useful scientifically it answers the question, can we use these Catalyst certificates without having to patch legacy clients? And I think we already have answered that question. The answer is no, right? We couldn't engineer our way out of needing to add a new client hello extension.
Yep.
So now we know the answer. You cannot use these certificate types without adding a client hello extension. So now the question becomes, well, what does that extension look like? How do we optimize it? Can we cover multiple cert types? And so I think, yeah, to me already there's great value in just answering the question. The answer is no, before we even get into any of the details on these slides.
Right, thank you. So the concept that we were doing, let me back up to the actual layout. So the idea is the client in the client hello could include this extension and identify what he's willing to support or what he can support. The server then can take a look at that and say, oh, so you can only do default. I need PQC, I can't talk to you, bye. They could look and say, oh, you do Chimera, but you only support native and the certificates I have, that's my legacies, not going to work, bye. Or they could say, well, I could do alternate or I could do composite. So if there's a matchup that's part of the negotiation, they can then proceed forward with the appropriate certificates. That was the basic concept that we were going for. Now, what you guys have actually done in the code, I don't know, but it's working.
That's basically what's been done in the code, yeah.
Yeah, okay. And so far, we've mostly done the happy path testing, right?
Yeah.
This is all beta code, so we're not doing production level. We haven't done error code handling. I mean, that's all going to be defined in the standard, but we haven't gotten to that far yet, and we'd like to get other crypto libraries engaged, get other folks engaged doing some of this testing.
Given, looking at this slide, given that this is a bit of an ongoing research design question, I think one of, if I can be bold enough to say, one of the open questions that we're still exploring is how this, what's on the slide, this new extension, interacts with the signature algorithms and signature algorithm certs extension. You know, because we're negotiating the certificate format now independently from negotiating which algorithms are used. And I think we still have to do some more work here to figure out whether there's non-trivial interactions between those two things that are in the client hello. And I think there's interesting things to explore there.
Yeah, in the current draft, which I don't know if you had a chance to take a look at, Max added a new extension to address that, but all I have done so far is note that there's this new extension. There's no words around it, so we are thinking about that, and we're working on that, but it's not in the current draft. So that's going to be beta 2.0 or something like that. And David's going, oh.
It'll be fine. It'll be fine.
So it's a bit in this, we add new stuff and then we see if we can simplify it down and remove some of it and add more stuff and see if we can simplify down and remove. Yeah, it's certainly an interesting project that I think is telling us what can be done with the minimal amount of impacts to existing clients. And it's not zero, but it's not crazy.
So that's why we're doing this in cooperation with others, because we actually, as we go forward, we actually want to have the code, we want to test the code, and we can go, oh, that seems to work, or oops, no, that didn't work. We're doing, though, this in X9 in one of the work groups. So right now, if anyone wants to get engaged, participate, you've got to be an X9 member. We don't really have a good solid mechanism to sort of open this up to the public like you can do in the ITF. We're having some of those discussions. We got some ideas, but we're not sure yet.
I couldn't possibly comment. We are actually X9 members.
You are a member. And Mike, this week? Maybe?
No comment.
So there's another part called subject matter expert. I believe you'd probably be able to drop into that if you had to as well.
Sorry?
You can join as a subject matter expert.
Oh, I already did that.
Yeah.
Yeah, he's one of them. But
That's
Yeah,
how
exactly.
I'm here. at
yeah,
the
we
moment.
were trying to get you guys fully engaged because you used to be members, so we wanted to get you back on board. Yeah. And we have other folks that we're talking to. I mean, X9 is pretty large. There's over 100 companies involved. We have, I don't know, 1,500 or so actual employees like myself who are actually engaged in doing X9 work. So there's a lot going on. I guess I should say, too, it's not just the banks. I mean, we have the merchants. We have service providers, U.S. Treasury, Federal Reserve Bank. They're all members, so everyone is aware of this. But we're just trying to get the word out that we're actually working on this thing. And if anyone has any thoughts or ideas, welcome to have that discussion.
Yeah.
Yeah.
I can't think of anything else to say.
Well, then I have a question for my panelists. Since you guys are, you particularly are doing the code, is there anything that we did right so far? Is there anything that we overlooked? Any thoughts of what we really should be focusing next? I'm going to put you on the spot.
Actually, well, that's not hard to answer because really, I think the only thing that we overlooked is what Max uncovered by discovering the need for the new extension. Yeah. I mean, other than that, it works, which is the important thing.
So I guess that's our next big step, is figuring out what that extension is going to look like and how we're going to use it. And do we add it to this extension? Is it two separate extensions?
Well,
and I don't know the answer.
Yeah. The other thing too, of course, is that, you know, having got the TLS extensions working and lined up properly, I guess the next big challenge will be like, all right, how do I update clients? And what do I do to service to make sure the clients that are pre-existing, of course, can keep talking? Mm-hmm. I mean, this is a process of crypto agility as much as anything else. And I'm not just saying it's agile because we're actually all standing and not sitting. It's like a stand-up meeting. That's really going to be the next challenge. If there's any gotchas in terms of, like, when you try and deploy the alt certificates, in theory that should just work. But yeah, it's whether there's going to be any gotchas there, and we won't really know until we've had a good crack at that.
Yeah, so for anyone who sat in my earlier talk yesterday on the financial PKI, I had mentioned we came up with multiple use cases. I'm guessing maybe about a dozen of those are related to TLS usage. But in the financial world, our services typically are not talking. They might be talking to a browser, they might be talking to a mobile app, but in reality, we do many application-to-application connections. So it's very, very different in our world. It might be a front-end web server dealing with a customer or dealing with some content network provider, and on the back end, it's talking to a database, it's talking to some other risk management system, and so we have many internal and external connections using TLS, but they're all focused on the financial services industry. So our requirements are a little bit different than in general use case.
To me, then, so you're sort of asking about next steps, I think. To me, what I'm looking forward to next from this project is that code point 3, code point number 3 there that says both. That I'm looking forward to exploring more, because that is doing something actually quite fundamental to the TLS handshake, and that it's adding 2 signatures from 2 different algorithms. And I think code point 6 also ends up doing something similar, potentially, in that you have 2 certs and you want to use both of them.
Yeah, I actually threw that in there because of something you wrote.
Hey, so that's non-trivial, right? Making those kinds of changes to the TLS handshake are pretty substantial changes. They'll need security review. They'll need formal modeling. Beyond just, can David hack something up that works? It's does it change the fundamental trust model and security model of the TLS handshake? And so I think this work is asking really interesting questions in an experimental test bed where we get to try them and then present them to the wider community for analysis.
Well, with regard to the code point 3, the both, I asked Anthony, when are we going to test that? And he said, I already did. We're replicating the tests. And I think I asked you and Roy the same question, and he said, oh, we already did that.
Yeah, no, as far as I know, it's working.
Yeah.
Although, as Mike says, yeah, you want to review it and see what it's doing when it's working. I mean, TLS as a protocol has been famous for working. SSL3 is a good example of something that was working.
Yeah, that's common in security, right? Just because the happy path works doesn't mean it's secure.
Exactly.
Yeah, and again, we haven't done any error testing. Yes, Bruno.
Can I ask a question?
Please.
Thanks.
Oh, time's up. Sorry. Go ahead.
Yeah, I'm going to go. One thing that I'm really curious to hear from you guys, especially in some of these variants where you combine both your classic and your PQC algorithms, back end, not the client, but back in the system that produces those certificates, there's some pieces of hardware likely protecting the private keys. And if I have to, I'm curious in terms of the assurance of the trust you get. How are those keys maintained in sync? Because if you're going to have 2 things to represent the final authority behind this certificate, how do you maintain that those 2 things are for somehow ever binded in union? They're married, and they're going to constantly be used very carefully, because you might have a certificate client that receives and validates one or both algorithms, but your backend system better not be breakable in terms of the assurance and the trust that you get from that system. So are you also looking at that implication in this work? Because I see an absolute makes sense to look at the clients, but the backend systems, we're going to be changing the way PKIs have been built for the last 30 years. You have a single source of authority in a box, and you control the box, and it's manage it properly, you're fine. But if we end up with 2 things that say this is your authority, we have to combine those things under a system. I'm curious about that because I think it's an important part of this process.
Well, I'll respond first because I've been thinking about this, and then you guys can correct me or whatever. I'm really glad you asked that because somebody said something yesterday and reminded me of something. So back in the day when we were just using ordinary DES and we had to convert to triple DES, somebody realized that even if the keys were encrypted and stored, the order of the keys made a difference. And they discovered there was attack vectors.
Exactly.
So we wrapped the keys, which we now call key block, and there's metadata around the keys, including the MAC and so on. I'm not seeing anyone today yet doing that with the combination of the private keys. And I think we need to think about that.
Yes.
Are we addressing that here? No. Should we? Maybe. And so that's a good discussion point.
Yeah, and what I'm suggesting is you guys are probably the first to start poking at that area. We have lots of things to do as a collection of this entire ecosystem. You're probably going to be facing that question sooner than many other people. I would suggest that's a topic that needs to be thought through, and that it may impact things like PKCS11 as an API. How do you combine 2 keys? Today's PKCS11 is a 1-to-1 mapping. There's no 1-to-2 kind of thing. So anyway, I suggest you're potentially not investigating it, but recommending someone investigates that. That's what I'm kind of.
The answer I would give is, I think what you're getting at is what to me fits inside the bubble of we need to do security analysis of the TLS protocol under these assumptions, because we have changed the assumptions. When you start doing TLS with multiple signatures from multiple algorithms, and depending on which scheme you're looking at, potentially from different authorities, and maybe you bring two certificates from two different CAs, two different routes, I think all of these assumptions need to get reevaluated. What does it mean to trust this handshake under that context? And I think, this project is really just can we get it to work? Can we get the happy path to work in a lab? I think to actually get these code points approved by the IITF TLS working group, we're going to have to go through all of that formal analysis type stuff. And I think there's, just because it works doesn't mean we're done with this work.
Okay, we have an online question. So Phil, can you online question, and then we'll
Sure.
quickly wrap up in the room, and then I've got a couple of housekeeping things that I've just got to share with you before you disappear.
This is for the panel. Do you think all kind of hybrids are needed? Why not just offer either classic or PQC at different endpoints?
It's probably a bit early. It's really a bit early to answer that, but at the moment we're trying to run with the idea that there is really no one size fits all. So for people, depending on what kind of circumstances they're facing in terms of upgrading clients and things like that, something like Delta could actually be something like Chameleon could be quite useful. Other people who are trying to preserve the idea that the classical algorithm will always be used in conjunction with the quantum algorithm because they're worried about the security of the quantum algorithms because they're new. They'll obviously go for the latest version of the composite standard. And then, of course, there's where we started originally, which is what's in X509 now, which is the alt profile.
PKI is complicated. There's a lot of weird PKIs on the planet with weird constraints. We've come up with situations where you can only put one cert on the device. This device is constrained to only have one certificate slot. Okay, well then you can't do a multi-cert approach because the client device can't hold two certs. So now we're looking at one of these weird hybrids. It's what Dave said. It said we don't know what we're going to run into. We're exploring options at this stage.
I think you almost answered my question here. Considering this specific use case, have you seen now actually any benefit of using alternative compared to just two classic certificates? Except what you just said.
I actually have drafted something, but we haven't had a chance to look at the work group. I actually had the idea of what if I had two classic certificates, one legacy, one PQC, and what if I wanted you to use one or the other or maybe both? How would I do that? And I was thinking, well, maybe we should use an attribute certificate that would identify how I'm managing my server, and then the client could go, oh, yeah, I could do that. But we haven't had that discussion yet.
I think it's the or maybe both case that is really complicated with two certificates. You can't sign a TLS handshake with two certificates, so we need to invent something new to be able to do that. And then at that point, is it just simpler to use a catalyst cert or a composite cert?
Yep.
Open questions, research project.
Hello, is this open? Yeah. A couple of questions. You said you're coordinating with the IETF. Have you actually talked to the TLS working group?
I'm not the TLS. Whoa, 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 whoa.
Yeah, that's why I put the names up there. So we have Anthony Hugh, who's very much involved. We have Max Palo, who's involved. We have Mike, who's involved. We got Tim Hollabeek, who's involved.
Those are lamps, not TLS.
True, but that's the closest we've got so far.
Okay.
Yeah, fair question.
Next question. Another question is client certs. Are you handling that?
We're not doing them yet.
Or MTLS like in the previous talk?
Yeah, not yet. That's not part of our happy path just yet.
Please, because of course, if you're saying, gee, you're the server, you don't trust the client, that's what the client certs are meant.
Yes. So how soon, David, will you have that in there?
Great. One more question in the room.
In theory, this extension applies in both directions, right? The client can advertise its support, the server can advertise its support. In theory, this extension can work in both ways. We haven't gotten there yet.
Excellent. One more question.
This is being presented as enabling classic certs and post-quantum certs by the same server device. Do you see this also being able to present certificates of the same type, both classic, both quantum safe, or some mix from different PKIs? So let's say I'm a bank, I offer from the same endpoint certificates chaining up to the X9er root, and for people out on the public web, certificates chaining up to one or even multiple commercial routes. Is this same extension able to facilitate multiple trust?
I think you can already do that today in TLS.
Can you?
I'd have to check whether there's a client hello extension that allows CA lists. I think that's the trust expression stuff that's coming. I think that's a bit independent from this work. I think this work is really focused on you have two different algorithms rather than two different trust authorities.
One of the things I did learn from working on this is a lot of the things I thought we had to do in this new extension was already in TLS in other extensions. So this has been a huge learning curve for me, and I very much appreciate that. So yeah, great question, but we'll have to follow up because the answer is, I don't know.
Thank you.
Excellent. Well, thank you very much. Really appreciate Mike, Dave, and Jeff.